Hello, everyone. So just want to point out how much effort everyone put in and how proud I am, especially the open-ended on the back. So if you crush the back, then I probably made a comment. And if I didn't, I'm sorry. But really, the last 5 questions is what really separates the college from the high school student. But if you actually put in the effort to answer the question, your ability to actually be a college level student will obviously be much easier than those that put in zero effort yesterday. All right, so I just want to quickly go over one version of the test. So I'll do version A right now. All right, so exam 1 formatted. All right, this one most of you got correct. So could not be decomposed. That's the key word there. Could not be decomposed. It's an element. Okay, boom. That's all you need to see. Right. So again, there's a ton of information. What's the key detail? Cannot be decomposed. You should write that down. Cannot be decomposed is an element. Look for cannot be decomposed because it's always an element. All right. Which particle diagram represents F2, right? The key information is F2G. If you see F2G, that's always 2 particles of F. This is F2, right? There's 2 F's, sorry for my circles. So F2, 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 STP is irrelevant, okay? Number 3, what is happening here? I see carbon dioxide going to carbon dioxide. So it's a physical change. A physical change is a change in their phase. So solid to gas. We never talked about bonds, so I don't know why half of you picked that. None of you really picked this. Half of you picked polarity, probably because you saw it in chromatography. That has nothing to do with solids and gases. All right, so it's particle arrangement. So solids have a close particle arrangement. Gases take the shape of a whole container. Right, they're more spread out. Releasing energy. Exothermic, getting colder. If you release energy, doesn't energy make you hotter? If you have a lot of energy, don't you get hotter? So if you release the energy, or like whatever, like you're sweating cools you down. So you want something that cools you down. So liquid to solid, and then gas to liquid. Those are all going down a cooling curve. Right? Temperature is kinetic energy. That was a sponsor. That was in flashcards. You guys did a graph on it. So if you didn't recall that detail, you probably had a bad time this week. Okay? A real gas, this is under Edpuzzle. This is like what we've been talking about, like air pressure and gas, like how does something become a gas? How do you crush stuff, right? So if you want to make a gas, you want to have low pressure. When you open your can of soda, you're lowering the pressure, and that sound you hear is a gas. So if you want to make a gas, you lower the pressure. If you want to make a gas, you heat it up. Okay? If you don't get that, I will show you an example in tutoring, or just message me if you need a better video to explain that. It's standard pressure, right? Whenever you see these like details, like that's just irrelevant. You'll eventually see that. You can just ignore that. Physical change is the keyword. So what's a physical change? Obviously it has to do with the 4 choices. And then when does it decrease or go down? Okay, so liquid to gas, that's hotter. Liquid to solid, that's colder. Solid to gas, that's hotter. Solid to liquid, that's hotter. Attention to detail. Liquid to solid is the only one getting colder. Cold bear, right? This, you have to read carefully again. Particle diagram, so solid, liquid, gas of one thing, okay? This is 2 things. This is 2 things. This is one of the 5 molecules of the same thing. 5 molecules of the same element, right? This is a compound. This is an element. So 2 and 4 are pure substances, which can be elements or compounds. Right. Next, According to table G, which substance is least soluble at 10 degrees Celsius? Least soluble is the lowest. So you have to go to table G and read all the details. 100 grams of water at 10 degrees Celsius. Oh, what does that mean? Let's go to our handy reference tables here. Sorry for the delay. Right. So 10 degrees Celsius, that's here. 100 grams of water, what does that mean? This is not grams of water. This is grams of all the solutes, not water. None of these things say water. It's water's here, okay? Because 100 grams of water is given. A lot of you get very distracted by that small detail. 100 grams of water has no effect on this problem. Why? Because it's already at 100 grams of water, so you don't have to do anything. All right, so 10 degrees Celsius and 100 grams of water, that should be a straight line, so let me fix that. 10 degrees Celsius and 100 grams of water. Here. So what's the lowest of those four choices? Going back here. Oh, geez. Nothing's showing. Whatever. So I see KNO3, Ki, NH3, and NaCl. So the lowest one, if I remember correctly, should be KNO3. Let's double check here. And I look over here. Yes, KNO3 is the third lowest. So let's double check nothing else is lower on the choices. Then we have SO2, which is not a choice. And we have KClO3, which is not a choice. So the only choice that's accurate is KNO3. Right? And again, the detail here is least soluble and 10 degrees Celsius. Right? And the substance, compound. They're all substances. So the next one is about gases again. Gases want low pressure and high temperature. So where is the lowest pressure? Oh, it's here. Where is the highest temperature? Boom, right? So it's 4. High temperature, low pressure. Okay. This was a really hard one. This is advanced. You have to really think about this and use your creativity and your imagination, whoever's an Einstein, right? So I have sugar, which is soluble in water. What that means is it mixes and dissolves in water. And you have sand. Sand will never dissolve in water. Okay, the properties of sand don't mix with water. We'll learn about that when we do chemical bonding. But anyways, right? Distilling is only liquids. So someone has to tell me why so many people pick distilling. Distilling is only liquids. Sand is not a liquid. So how could it be distilling? Right? So you can eliminate that. So if you know sand is there, you have to filter it, right? How do you filter something? By adding more sand? No, you need water to filter. It's filter. You filter something with water in it. Right, so you add water, you mix it around, you filter out the sugar water, and the sand will be left behind. And then you could evaporate the sugar water to get the sugar remaining. Right? I'll just make ice cream with you guys, and hopefully that'll make more sense later. If you can't imagine it. Random motion of particles, right? This is something you should come into college knowing, but you're not in college yet, so that's why I'm giving you a second chance. A chemical change is a reaction. An electrical change is when you have electricity being shared, so it's usually like metal to non-metal. Nuclear change is like nuclear fusion. Hydrogen plus hydrogen gives you helium. A thermal change is heat, okay? Or temperature. So the faster things move, the faster you move, the more heat you have, the more thermal energy. The faster anything moves, the more thermal it has. Okay. So again, kinetic energy is temperature. So if you got question, I believe it's 5. If you got question 5 right, if you knew that kinetic energy was temperature or measures, if you knew temperature measures the kinetic energy, then you should get this question right as long as you're paying attention to all the details that are important. So I have kinetic energy, which is temperature. When does it go up? All right, version B said go down. So version A, when does it go up? This is temperature, it's going down. This is staying the same. This is staying the same, right? This is freezing here. It's a physical change. And this is boiling here, liquid to gas. It's a physical change. They're changing in phase. Over here, I'm clearly getting hotter. So that's why the answer choice is 4. Okay. 14. Again, this was your sponsor. Right? Kinetic energy is like kinesthetics. Learners, you're moving. Potential is not moving. You have the ability to move. You have the potential to move. You have the ability to move, but you're not moving. Can you move and not move at the same time? Please answer that. Can you move and not move at the same time? Okay, the answer is no. So you could eliminate this because you can't move and not move at the same time. You could eliminate that because you can't move and not move at the same time. And then if I am boiling something, this is solid, melting, liquid, boiling, gas, right? Solid, liquid, gas. So if I am here, this is kinetic energy, this is potential, this is kinetic, this is potential, this is kinetic. So when you're boiling, that's potential energy increasing and kinetic stays the same, right? That's very difficult if you've never heard kinetic energy or potential energy before, and you've never seen a heating curve. Okay? So that's why your grade is measured on growth, not your overall just score. That's child abuse. Right? Crystal. What do you think when you hear the word crystal? Do you think solid, liquid, gas, or solution? Have you seen a crystal? It's a solid. Your salt can crystallize in water. Okay, or from a solid. Sugar can crystallize. If you ever made rock candy, those are sugar crystals. I'm not making rock candy with you guys. I spent 2 weeks one year doing rock candy. It was fun, but it was like, I mean, maybe we'll do it. Okay, sorry. Anyway, so which type of matter is represented by the particle diagram? Right, like a 99% of you got this correct. So again, it's pure, right? So it can't be a mixture if it's pure. And then it's a compound. Why? Because it's 2 colors combined. If it's 2 colors separated, then it's a mixture. Okay. Integrity. So now this one says a mixture. So you're looking for not one thing, but 2 things. So this is one thing, it's a compound. This is one thing, it's an element. This is one thing, right? And it's also a gas. So it's one thing, it's all 4 the same. This is 2 things, not all 4 the same. 2 are the same, and these 2 are the same. So it's 2 different things, right? Our favorite compound is lead chloride. This is going to give people jitters here. It's AQ. What does that mean? It's a mixture. An element can never be a mixture because it's a substance. A compound can't be a mixture. So, and there's no such thing as a heterogeneous compound anyway. But if it was a heterogeneous mixture, it wouldn't mix with water. You should know from your notes and your Google Slides that AQ is a solution. And a solution is also known as a homogeneous mixture. Right, I'm not writing that out, right? It's a homogeneous mixture. Next question. Dilute. Okay, if you came into high school not knowing what this meant, that means watered down. Right? You definitely need to know that before you go to college. Dilute is watered down. If you want to make something, so dilute and concentrated are basically the opposite, right? So if you make something more dilute, you add water. If you make something more concentrated, you remove the water. Like orange concentrate. Do you know what that is? Google it. Orange concentrate. What do you need to do? You add water to dilute it so it's drinkable. Also, don't drink orange juice. Eat the orange. Right? Unless you're an athlete, you should eat the orange. Eat the orange. Eat it. Eat fruit. You got to eat fruit. Get your micronutrients, right? So your brain can function properly. Which statement describes the component of a mixture? This was literally something we did yesterday about distillation, right? That's probably why you got the other one confused, right? Proportions of a mixture can always vary. That's just a detail you should always look for. Mixture, the proportions can vary. Even a homogeneous mixture, the proportions can vary. You make a mixture of sugar and water. Do you have 50% sugar and 50% water? If you do, it's called diabetes, right? You don't do that. Integrity. So kinetic energy is temperature. Temperature. Compare the temperature of CD and EF. EF is at a higher temperature. Or you could say CD is at a lower temperature or lower kinetic energy. Please come to tutoring if that is still unclear. Right? But please come. Right. Table G, the minimum mass of KCl, salt chloride, sorry, potassium chloride, which is in your frozen food because you can't tell what's in it. And the food industry doesn't care about you. Saturated at 90 degrees Celsius. So you go to 90 degrees Celsius and KCl. The same thing you've been doing for like 2 weeks. Right. So again, go to 90 degrees Celsius and you go to KCl. Boom. What is that? Right? If you said anything from 52 to 56, that is correct. Thank you. Right. So going back to this here, that is about 52 to 56. So if you said 57, sorry, that is too bad. That is a 5. 52 to 56 is acceptable. All right, this one, did you have enough stamina? Are you college ready? Did you have enough stamina to read this carefully and find the key detail? It says a liquid. All right, so this is a liquid. It's a liquid of a molecular substance or a molecule. Both the beaker and liquid are at 194. So 194 is about here. So it's a liquid there. So it's cooled down. What can possibly happen when you cool down a liquid? Right? It freezes. Liquid to solid's freezing. Right, sorry, it's freezing. You have to really pay attention. College ready. It's not easy for the majority of people that are 14 or 15 because you're not 18 yet and your brain hasn't fully developed yet. Right? Solute and solvent. Right? You should come into high school knowing what a solvent is. If you don't know what a solvent is, it's stuff you basically clean with. So what do we clean with usually? Water. What else do we clean with? Alcohol, like rubbing alcohol. Even ethanol, the stuff you drink, or I'm sorry, the poison you drink. It is a poison. You should know that. Alcohol is a poison. It's a known poison. It's like, and it turns into formaldehyde. This is a known carcinogen. Right? So solute is what's being dissolved. So it's NaCl, salt. What's cleaning the salt, or what can remove salt? Water. Okay. And again, no, sorry. And now, what's the relationship between solubility and temperature of SO2? Okay, that's the key detail. So I go to SO2 on table G, because that's what the question says. So go to table G, go to SO2, and what is the relationship between solubility and temperature for SO2? Oh, it goes down. As temperature increases, solubility goes down. Right? So I'm hoping that helped a little bit. Your grade is measured on growth. So if you got an 80, you better get at least a 90 next week. Right? If you got 100, I'm giving you regions. Right? If you got like a 65, what do you think you could do? Can you get an 80? Can you 75? You'll decide on Friday or today, in a couple hours. Right? Thanks for watching, and I will see you soon.